This video is an introduction to hypothesis testing. Hypothesis testing is where a claim is made about a population parameter based on evidence collected from a sample. And then what we do is we do a test to find out if we are going to accept or reject the claim. So it's a little more in-depth than that, but that is pretty much the basis of what it is. So first want to look at some types of claims that can be made. Let's look at some examples of types of claims. In doing this, I also want to think about what the population parameter is that we are making a claim about. The parameters that we can make a claim about are mean or proportion. We won't really make a claim about standard deviation, though you could if you wanted to. It's not too beneficial to us. So the claim, first example, is in a sample of 100 people, 66 eat fruit daily. Test the claim that the percent of people that eat fruit daily is equal to 65%. So a percentage, the parameter that is being studied here is proportion. So my claim is that my proportion is equal to 0.65. All right, let's look at the next example. A friend on social media claims that the average number of books Americans read is less than 5 per year. So the word average is the key here. Because of the word average, we know that it's a mean. So we're looking that the average is less than, so the mean of books is less than 5 per year. So our population parameter is mean, and this is the claim that we're going to test. The next claim says the percent of LDS BC students that have pets is greater than 20%. So because it's a percentage, my claim is a proportion, so my claim would be my percentage is greater than, so greater than 0.20. And I'm just going to change my percent to a decimal. All right, the last one says the number of children that families had in the 90s was 2.7 per family. Test the claim that the mean is no longer 2.7. So we have a mean, and we're testing the claim that it is no longer equal to 2.7. So we say it is not equal to 2.7. These are all different things. You can have your original claim be equal to, you can have your original claim be less than, greater than, or not equal to. In hypothesis testing, there will be some things that you need to understand before you actually perform the test. The first thing that you need to understand is what a null and alternative hypothesis is and how we use them. The null hypothesis is what will be tested. This will always contain equality. So if our original claim that we're given has equality, that's part of the null hypothesis. If it doesn't have equality, it doesn't matter. The null hypothesis still has equals to. We are always going to assume that the null hypothesis is true, and then we will find evidence to prove it is not. Okay, the null hypothesis, the notation will be H for hypothesis not. That means that not can be like a starting point or original, so that's why we call it H not. The alternative hypothesis will come from the original claim. We are trying to find evidence to support the alternative. So we're trying to prove that the null is false and the alternative is true. Because they will always be opposites of each other, one must be true and one will not. The alternative hypothesis we denote as H1. Now there's some important things to know about the alternative hypothesis. Let's go over those. So if the original claim contains equals to in the claim, the alternative hypothesis will be the opposite. So the original or the alternative then would have a not equals to. because it has to be the opposite of the null, and the null always contains equality. So the null always has to have an equals to. So if the original claim does contain not equal to, the alternative hypothesis is also not equal to. And that is because my null hypothesis has to contain equality and our alternative has to be the opposite. So both of these will have a not equal to. And the last thing is if our original claim contains greater than or less than, then the alternative hypothesis will correspond to those signs. So that means it's either going to be equal to in the null or greater than in the alternative, or equal to in the null, less than in the alternative. So now I want to look at those problems we looked at before where we found the parameter, and we're going to write the null and the alternative hypothesis of those. In our first example, finding the null and alternative hypothesis, let's see. We have a sample of 100 people, 66 eat fruit daily. Test the claim that the percent of people that eat fruit daily is 65%. So my null hypothesis is about a proportion. So my population proportion is equal to 0.65. Because I have equality in my original claim, my alternative hypothesis then would be that my proportion cannot equal 0.65. For the second problem, a friend on social media claimed that the average number of books Americans read is less than 5 per year. So my null hypothesis has to say that my mean equals 5 per year. It has to say equals to in the null. Then the alternative is whatever the original claim is trying to say. So then that would mean that my mean is less than 5. For the next one, the percent of LDSBC students that have pets is greater than 20%. So that would mean that my null hypothesis is that my proportion has to equal 0.20. So then my null hypothesis is that my proportion has to be greater than 0.2. And the last one here, the average number of children that families have in the 90s was 2.7 per family. Test the claim that the mean is no longer 2.7. So because it contains equality, we have that our null of our mean first has to equal 2.7. So then our alternative hypothesis is that our mean cannot equal 2.7. Okay. What we will end up doing is we will take the null hypothesis and the alternative hypothesis, and we're going to find a test statistic, and we're going to see if we're going to lie in the null region or the alternative region. So on these, we'll have a 95% confidence level. That 95% or 0.95 will relate to the null hypothesis. Okay? And then if it's a not equal to, we will have the area in each of those tails. So either it's inside here or it's outside. That's what not equal to means. It's outside. So that means the area for the two tails is equal to 0.05. So inside here would represent the null. On the outside, we would represent the alternative. Now the test looks a little bit different if it can be equal to or not equal to. On not equal to, or less than, we have here either we're going to fall in the null region or we're going to be less than the null region. That's what less than means. So this right here, if we have a 95% confidence level, 95 will represent my null, and then 0.05 will represent the area of my alternative. And it will be the less than area. All right, let's look at a greater than is kind of a similar concept. So greater than here, well, that was really bad. We have our null, which is a 0.95, and we want to find the area greater than would be the alternative. And that, if it's a 95% confidence, that area is 0.05. All right, so I'm not going to do the last one because the last one actually is represented in the very first problem. So what we're going to end up doing is we will find a test statistic and see if the test statistic is in the null or the alternative region. If our test statistic lies in the alternative region, we reject the null, which means we accept the alternative. If our test statistic is in the null region, then we fail to reject the null. Now this video was just for introducing the concepts of hypothesis testing. In the next video, we'll learn how to actually do the hypothesis testing.